Hi guys, welcome back. So what we're going to be looking at in this video, this is continuing on chapter 6.5, and they have quite a few examples on finding values for inverse functions. They also have quite a few questions on finding derivatives. And I think that's a little bit interesting considering the chapter is supposed to be on integration of inverse trig functions. But anyway, we need to show you how to find the derivative of these functions, and then once we've found the derivative of these functions, we should be able to see how we can then go ahead and find the integral. So this chapter is a little bit all over the place. I don't know if I'm the biggest fan of the way that this chapter is written, but anyway, let's go ahead. Let's have a go at this question here. So this is an example of a simple familiar derivative using an inverse sine function. And so this set of derivative rules here, this can be found on page 361 of your textbook. And so since this question here, the inverse of sine, is just simply substituting in these values, this is going to be a very easy solution. Okay, so let's write our rule. So we always do FSA. So our rule is that dx of inverse sine of x over a will be equal to 1 over the square root of a squared minus x squared, where x is an element of negative a to positive a. So we don't need to write that bit. I'll just write this bit here. Now let's substitute in the values that we know. So in this case, we know that a is going to be equal to 4. So this is just going to become ddx of sine x over 4. And that's going to be equal to our answer, which is 1 over the square root of 4 squared minus x squared. Or we could write that as 1 over the square root of 16 minus x squared. And that's it. I can go through and I'll show you another example, but that is as straightforward as we can be. It really isn't too tricky. It really is just substituting some values into an equation. Let's do another example. Okay, so this is question 2a, and this is on page 372. And again, I've just written the appropriate formula from those inverse trig functions from before. Okay, so now we've got a slightly different value for a here. So previously when we had x over a, we could rewrite this as 1 over a times by x, couldn't we? And then when we substituted in this value here, we found the reciprocal of that. So we're going to do the same thing here, except now 1 over a is going to be equal to 3 over 4. So when we find the reciprocal, that's going to be 4/3, okay? So a is equal to 4/3, and this is the value we can substitute in now. So this is going to be nice and simple. So the derivative of inverse cos of 3x over 4 is going to be equal to -1. See how this is different from sine, because sine is +1. Over the square root of 4/3 squared minus x squared. So that's going to be equal to -1 over the square root of 16 over 9 minus x squared. I think we could do maybe one more tricky example. All right, this is question 5b on page 372, and I've chosen this one again just because it's a little bit more complex. So what we can do for this one, now this is kind of getting a little bit crazy. Let's write our function actually over here just so you guys know. All right, so I just pop that there. And this is different compared to our previous function because our previous function had a fraction. It didn't have this -3 value. So just to make this a little bit easier for myself, I'm going to use the chain rule, and I'm going to let u equal to the inside function, and I'm going to find the derivative of u with respect to x, and so that is going to be 2x over 5. Okay, so the next thing I'm going to do, let's rewrite this, and this is going to be, we can write this as y is equal to the inverse of cos multiplied by u. We're going to use this rule here, and in this case, instead of using x, we're going to be u, and a is going to be equal to 1, because we can just rewrite this in this fractional form, and we can see pretty easily that a will be equal to 1. So then if we're going to find the derivative of y now with respect to u, it's going to be equal to -1 over the square root of 1 squared minus x squared. Okay, so now using my chain rule. So the chain rule states that dy dx is equal to du dx multiplied by dy dx. And if I dy du. And then if I multiply these two, algebraically what's happening is we're cancelling out, I hate that term, we're dividing du's to get the value of 1 and we're left over with dy dx. So that's why we're going to use the chain rule to do this one. So that's going to be 2x over 5 multiplied by negative 1 over the square root of 1 minus x squared. Okay, so let's simplify this now. So this is going to be negative 2 over 5, 1 minus x squared. And we could go ahead and we could probably try and do some stuff with this stuff underneath the square root if we wanted to, but I think I'm going to leave it there. So there you go. There's some examples of 3 simple familiar type questions with some varying degrees of complexity. Not too tricky though. All right, I will see you in the next one, finally, for some integration of these inverse trig functions.